Have you ever wondered how light interacts with matter, or why time only seems to move forward? Today, we're diving into a groundbreaking discovery that might just revolutionize our understanding of the universe. Researchers from Tampere University and the University of Eastern Finland have recently unveiled a new wave equation. This isn't just any equation. It's one that links wave mechanics with Einstein's general theory of relativity and even the elusive arrow of time. So, what does all this mean? Whenever light interacts with matter, it appears to slow down, a phenomenon well described by standard wave mechanics. But what happens when we consider light experiencing acceleration at the boundary of different materials? Until now, this acceleration hasn't been fully accounted for. What if the speed of a wave isn't always constant? By assuming variable wave speeds, the team derived what they call an accelerating wave equation. This new approach not only solves the equation, but reveals behavior reminiscent of relativistic effects. During their research, they realized they needed a constant reference speed, the speed of light in a vacuum. This insight led to an exciting discovery. The equation indicates a fixed direction of time, also known as the arrow of time. Unlike thermodynamics, where entropy shows the direction of time, this new equation suggests that accelerating waves inherently flow forward in time. This means even single particles, which previously seemed ambiguous in their time direction, now align with a fixed arrow of time. But that's not all. This framework also addresses a century-old debate in physics. What happens to light's momentum when it enters a medium? This new model shows that, from the wave's perspective, its momentum remains conserved thanks to relativistic effects like time dilation and length contraction. The implications of this discovery are vast. It allows researchers to analytically model waves in time-varying materials, such as the exotic disordered photonic time crystal. These materials could potentially slow down waves exponentially while increasing their energy, opening doors to new technologies and experiments. This groundbreaking research bridges everyday optical effects with the profound principles of general relativity, providing a new understanding of why time has a preferred direction. What could this mean for the future of physics and our grasp of the universe? So, what do you think about this cosmic glitch in gravity? Could it reshape our understanding of the universe? What new mysteries will we unravel next? Drop your thoughts in the comments below. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.